Math 112, Test 3 Solutions. If f is a function of x and y, evaluate f of 3 comma 5. F of 3 comma 5 means replace every x with 3 and replace every y with 5. There's y is 5. This is 9 plus 30 plus 25. 39 plus 25 is 64. That's it. F of 3 comma 5 is 64. Z is a function of x and y. The partial derivative of z with respect to x, symbolize z with an x subscript, means pretend y is a constant. So before we do this, we're going to rewrite the given z equals 2x cubed. I'm going to rewrite this term in the order 3y times x. The partial derivative of z with respect to x is 6x to the second power. Since we're pretending y is a constant, the derivative of a constant times x is just the constant. Just like the derivative of 8x would be 8. The derivative of 3yx is 3y. And similar here, the derivative of negative 1x is negative 1. Here's f is a function of x and y. It can be rewritten like this. F is a function of x and y. Instead of the square root sign, we can put x squared minus y squared in parentheses, raised to the 1/2. The partial derivative of f with respect to y, that's f with a y subscript, means pretend x is a constant. We're going to have the 4 bells here. 1/2 times 1. Ding. X squared minus y squared gets copied. Ding. The exponent 1/2 becomes negative 1/2. And then that's the third ding. The fourth bell is the derivative of what's inside the parentheses. With respect to y, the derivative is 0 minus 2y, because we're treating x as a constant. That would make the derivative of x squared 0. 0 minus 2y is the derivative. If with respect to y means y is the only variable. And 1/2 times negative 2y is negative 1y. And this expression with a negative exponent, if we put it into the denominator, it becomes x squared minus y squared to the positive 1/2. The exponent becomes positive because I put that in the denominator. So that's the answer, which also could be written negative y over the square root of x squared minus y squared. Riverside Appliances has the following production function for a certain product. P is a function of x and y. P is the number of units produced with x units of labor and y units of capital. If we want the number of units produced, that's P, number of units produced, with 2,500 units of labor, that's the x, and 1,700 units of capital, what's units of capital is y. That means replace x with 2,500, replace y with 1,700. That's 1,800 times 2,500 raised to the 0.621 times 1700 raised to the 0.379. So I'm going to get a calculator out to calculate this. Eighteen hundred 1800 parentheses 2500 close parentheses raised to the 0.621, don't need the zero, right arrow, open parentheses 1700 close raised to the 0.379, don't need the zero. And we're going to round this to a whole number. I'm going to say it's 3888064 in this box. We're going to put 3888064. The partial derivative of p with respect to x, so we're going to treat y as a constant. So I'm going to rewrite the order of this. 1800, y, which is a constant, raised to the 0.379. So all of this is a constant, and it's times x to the 0.621. To find the derivative with respect to x, I mean the partial derivative with respect to x, we take this exponent, 0.621, times this constant. Yes, I'm pretending y is a constant. So the constant is 1800 y to the 0.379. And then x to the 0.621 becomes x to the whatever 0.621 minus 1 is, which is the new exponent is negative 0.379. And now I'm going to calculate this when y is when y is 1700 and x is 2500. Here's the calculator buttons I'm going to press. Clear this. So it was 0.621 times 1800 times 1700 raised to the 0.379 times 2500 raised to the negative 0.379. And we're going to round this to the nearest whole number, 966. So that's what's going to go there, 966. And now we want the partial derivative of p with respect to y. So we get to pretend x is a constant. So the derivative of this, all this I'm underlining is a constant. The derivative would be 0.379. That's the exponent times this underlined constant, 1800 x to the 0.621. That's just a constant. And the y becomes y to the whatever 0.379 minus 1 is. The exponent is 0.379. We're subtracting 1, and we get negative 0.621. And I'm going to calculate this when x is 2500 and y is 1700. So it's 0.379 times 1800 times 2500 raised to the 0.621 times 1700 raised to the negative 0.621. And we'll round this to the whole number, 867. That's what goes there, 867. A concert promoter produces two kinds of souvenir shirts. One sells for $18 and the other for $25. The total revenue for the sale of X thousand shirts at $18 each and Y thousand at $25 each is given by R for revenue is a function of X and Y. $18 for each of the X shirts and $25 for each of the Y shirts. And the cost in thousands of dollars of producing X thousand of the $18 shirt and Y thousand of the $25 shirt is given by this. C is the cost, R is the revenue. Profit, the word profit means revenue. That's how much money is taken in, you get from your customers, minus your cost. What's left after subtracting is called profit. So we're going to take the revenue, which is given 18x plus 25y, and subtract the quantity 4x squared minus 6xy plus 3y squared plus 20x plus 19y minus 12. Revenue minus cost, we call that profit. This minus distributes. So we're going to have 18x plus 25y, and we're distributing the minus, so we get minus 4x squared minus a minus, so that's plus 6xy, minus 3y squared is what I just said, minus 20x, minus 19y, but then at the last term we have minus a minus 12, so that's plus 12. 18x minus 20x is negative 2x. 25y minus 19y is positive 6y. Negative 4x squared, there's no other x squared term. There's no other xy term besides the positive 6xy. There's no other y squared term besides the negative 3y squared, and there's no other constant term except for the positive 12. So all of this, red, green, and all the blue, all of that is the profit function. To maximize profit, we need the partial derivative of p with respect to x, so we're going to treat y as a constant. The derivative of this the polynomial, if I'm pretending y is a constant, is negative 2. The derivative of 6y will be 0. The derivative of negative 4x squared is negative 8x. If y is a constant, this term is 6y times x. The derivative of 6y times x is 6y, because y is a constant. And the derivative of negative 3y squared is 0, because y is a constant. And the derivative of 12 is 0. The partial derivative of p with respect to y, now we're going to treat x as a constant. That makes the derivative of negative 2x 0. The derivative of 6y is 6. The derivative of negative 4x squared is 0, because x is a constant. The derivative of 6xy is 6x, because it's a constant times y, so the derivative is just the constant. The derivative of negative 3y squared is negative 6y. And the derivative of 12 is 0. To maximize or minimize when there's a function of two variables, we find when these partial derivatives are both equal to 0. It's something you should have learned in algebra, is you can add these equations like this. Negative 2 plus 6 is 4. Negative 8x and 6x is negative 2x. These y terms add up to 0. 6y and negative 6y is 0. And 0 plus 0 is 0. So if we subtract 4 from both sides, 0 minus 4 is negative 4. And we get x equals 2. Now we're going to replace x with 2 in either one of these equations. It doesn't matter which one. I'll use the second one. 6 plus 6 times 2, x is 2, minus 6y equals 0. That's 6 plus 12 minus 6y equals 0. 6 plus 12 is 18. 18 minus 6y equals 0. Subtract 18 from both sides. 0 minus 18 is negative 18. So y equals 3. X is 2 and y is 3. So x 1,000. X is 2. So that's going to be 2,000 of the $18 shirts. And y is 3. Y 1,000. So y is 3. So that's going to be 3,000 of the $25 shirts. Cost of manufacturing, or cost for a manufacturer producing X units per week is given by C of X. The marginal cost just means the derivative of the cost. It is the exponent 3 times 0.005, which is 0.015. X cubed becomes x squared. The next term is plus 2 times 0.6, which is 1.2. X to the second becomes x to the first. The derivative of 10x is just 10. And the derivative of 100 is 0. The marginal cost, that means C prime, when x is 50, is 0.15 times 50 squared plus 1.2 times 50 plus 10. Putting that in the calculator, 0.15 times 50 squared plus 1.2 times 50 plus 10 Okay, so I'm getting the wrong answer because this is supposed to be like from above, 0.015. Somehow I missed the 0, but everything else is okay. And this comes out to be 107.5, but to be dollars and cents, we put a 0 here. That number is called the marginal cost when 50 units per week are manufactured. This entire question is all algebra and arithmetic. C of 50 means 0.005 times 50 to the third plus 0.6 times 50 squared plus 10 times 50 plus 100. Just in here, everywhere there's an X, I'm putting 50. And we'll get an answer for this. And then C of 51 is going to be 0.005 times 51 cubed plus 0.6 times 51 squared plus 10 times 51 plus 100. So I'll put those in my calculator. 0.005 times 50 to the third plus 0.6 times 50 squared plus 10 times 50 plus 100. That comes out to be $2,725 exactly. But I'll add and 0 cents just because I said near a cent. This is no rounding here. It's exactly that. Now replacing x with 51, this second line up here comes out $2,833.86, rounded to the nearest cent. So if the production is increased from 50 to 51, the cost goes from this cost to this cost. So the cost is increased by 2833.86 minus 27.25 and 0 cents. So the increase in cost is $108.86. Let's just subtract these two answers up here. And that should be close to the marginal cost when X was 50. $108.86. That's pretty close to $107.50. This is showing what marginal cost means. It's how much cost would increase if this was increased a little bit. Another way to say a little bit is to say marginally. That's why it's called marginal cost. But this was all arithmetic, really just arithmetic. Plug in 50 to get this number, plug in 51 to get this number, subtract these numbers to get the increase in the cost. It's all arithmetic. There's no calculus. There's not even algebra here. Equilibrium is when demand, in this case that's 50 minus 4x, and supply, in this case that's x squared plus 5. When those are equal, we'll have equilibrium. So we're going to make this equation 0 equals x squared plus 5. Subtract 50 and add 4x to both sides. We rewrite this as x squared plus 4x. 5 minus 50 is negative 45. And we have equals 0. We hope that we can factor this. X squared is x times x. 45 is 9 times 5. Positive 9 times negative 5 is negative 45. So this is factored correctly, and this is true when x plus 9 equals 0, or when x minus 5 equals 0. X plus 9 equals 0 when x is negative 9. And we don't use negative numbers for x. X is the number of items produced, or either supplied or demanded. It's not ever a negative number. Add 5 to both sides over here, x equals 0 plus 5. So that number makes sense. The equilibrium point has 5 as the x coordinate. The y coordinate, we plug 5 into either one of these. So we can say 50 minus 4 times 5, or we can say 5 squared plus 5. We don't have to do both of these. That's 50 minus 20, which is 30, and that's 25 plus 5, which is also 30. So it makes the equilibrium point 5 comma 30. This has to be in parentheses. Has to be. Not optional. Parentheses not optional. Consumer surplus, we integrate what consumers do. Consumers demand things. Producers supply. So consumer surplus, we're going to integrate the demand function. Don't forget dx. And it's always from 0 to the x coordinate of the equilibrium point. And then it's always minus the product of these coordinates. The product of, in this case, 5 times 30. We'll distribute the integral symbol. The integral of the first term, which is 50, also distribute dx, minus the integral of the second term, which is 4x dx. After that minus sign, we have 150. The integral of dx is just x. There's a 50 in front. The integral of x dx is x squared over 2. There's a 4 in front. We put a bracket here with 0 and 5. So all the x's are going to be replaced with 5. 50 times 5 minus 2, because we have a 4 over 2. That's why I'm just getting 2 there. And replacing x with 5. And then it's going to be minus 0, because this number down here is a 0, and both terms are 0 when x is 0. Fifty times 5 is 250. 5 squared is 25, and 25 times 2 is 50. 250 minus 50 minus 150 is 50. So $50 is called the consumer surplus at the equilibrium point.